Question 11, we have a smooth sphere of mass 10, moving at 10, impinging directly on another smooth sphere of mass 50, moving in opposite direction at speed of 5. So we have our masses of 10 and 50. We have before and after 10 and in the opposite direction minus 5. And we have E as a half, and we're asked to find the speeds after impact and the magnitude of the impulse as well. So we call this Pi and Qi. So V1 minus V2 over U1 minus U2 equals minus E. Will give us P minus Q over 10 minus 5 is equal to minus 1 over 2. 2P minus 2Q equals minus 15. And for my conservation of momentum formula, M1U1 plus M2U2 equals M1V1 plus M2V2. We're going to have 10 by 10 plus 50 by minus 5 is equal to 10P plus 50Q. So we're going to get 10P plus 50Q is equal to 100 minus 250 minus 150. So I could divide it by 10 anyway. I'm at P plus 5Q equals minus 15. And then multiply it by minus 2 to get minus 2P minus 10Q equals 30. And then bring this guy across. 2P minus 2Q is equal to minus 15, giving us minus 12Q is equal to 15. So Q is equal to minus 15 over 12, which is equal to 3 goes into both 5 over 4. And Q is 5 over 4. We have this equation here. P plus 5Q is equal to minus 15. So P plus 5 times Q equals minus 15. P minus 25 over 4 equals minus 60 over 4. So P is minus 60 plus 25 minus 35 over 4. And we're asked for the impulse, aren't we, as well? The impulse here, impulse mv minus mu. So we have our 10. Let's use that. Just got the speed there to be minus 35 over 4, and the speed before is 10. Minus 350 over 4 minus 100 over 4, which is 400 over 100, sorry, which is 400 over 4. Which is minus 750 over 4 minus 19387.5 measured in Newton seconds for the impulse, or the magnitude of the impulse. This is the impulse here. This is the magnitude of the impulse. That is in the I direction. Question 12, state Newton's law of restitution for direct collisions. So this is for two bodies impinging directly. This V1 minus V2 formula is what we need to explain. We've been bringing the U1 minus U2 underneath for our ease of use, but this is for two bodies impinging directly. The relative velocity after impact, this V1 minus V2, is equal to a constant E, this E times their relative velocities before impact, in the opposite direction, I think, is added in at the end of that. So the law of conservation of momentum is your M1 U1 plus M2 U2, which is when a system is closed, the total momentum will be maintained or conserved. So that's those two. Let's look at B here. An elastic sphere, initially at rest, 19.6 meters above the ground. Okay, well, let's see what's going on. There's something here. It's going to hit the ground. 19.6 meters is equal to distance its initial speed is 0. It's going to hit the ground at a particular speed, and the acceleration here is going to be gravity. So what else is going on here? We're asked for, it falls and bounces off the ground, and we're told the coefficient of restitution is 0.8. Find the greatest height attained after the first bounce. So what's happening on the way back up? So it's going to hit the ground, and it's going to go back up with an initial speed, which we're going to work out now to be this v. We're going to have, it's going to stop. The acceleration is going to be minus gravity, and we're looking for the distance that it's going to travel. So this s here is what we're looking to get at the end. So let's find out the speed it's hitting the ground at. We have VUAS, so we can use v squared is equal to u squared plus 2as. This v squared that we're looking at, or this v that we're looking at, it starts at rest, and it's traveling a distance of 19.6. So 2 by 19.6 by a, which is going to be g. Well, we can put that in as 9.8. So that's actually going to be 9.8 or 19.6. So that's v squared is equal to 19.6 to be squared. So v is equal to 19.6 here. So that's the speed it hits the ground at. So that's this u over here. So let's change it over to here. We've got 19.6. It's going to come to rest at some point before falling back down, and we're looking for s in this case. So now this speed of 19.6 that it's going to go back up at is being tempered by this e. So this 19.6 we'll have to multiply by 4/5 to get the speed that it's going to go back up at. So that is going to give me 15.68. So we should be able, then we have u, v, a, s. So s we can use again, v squared is equal to u squared plus 2as. So this v that it's going to stop at the top of its flight is going to be equal to u, this 15.68 squared plus twice a is minus 9.8, and we're looking for s. So s is equal to 15.68 squared over 19.6, and typing this into a calculator, s is equal to 12.544 meters. That's going to be the greatest height attained after the first bounce. 12 part C, we have a gun of mass 2 kilos. So we have a mass of 2 for object 1. For the bullet of mass 10 grams, 10 grams is equal to, as a kilo, well, 0.1 of a kilo will be 100 grams. So we got 0.01 will be 10 grams. So that's 0.01, a big difference to 2. What else going on here? With a muzzle velocity of 300 meters a second. So that's a speed. And that speed is the bullet when it comes out of the gun. So that's going to be 300 there. And find the velocity of the recoil of the gun. So that's afterwards. So that's going to be my V. So I can call this one here V. So beforehand, they're both at rest. I think this is the way into this question. Let's see, will this work for us? So we do M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. We're going to get 0 plus 0 is equal to 2V, and that's the only unknown here, 2V plus 0.01 times 300. So that's going to be 1 by 3. So 2V is equal to minus 3. V is equal to minus 1.5. meters per second. So that's the velocity of the recoil of the gun. And then we're asked for the constant force required. So again, once we see constant force, force is equal to ma. So we need in some way to find acceleration here. So to find A, they've given us a distance of 50 millimeters. 50 millimeters is 5 centimeters, which is 0.05 of a meter. So we have V, we have S, 0.05. What else have we got here? We know that it's going to come to rest, so that we'll actually call that V. We'll call U 1.5, the initial speed of the gun, and then it's going to come to rest. So this V and this U are the same. And we're taught we have distance, we have initial speed, it's going to rest. We're looking for A, so we can plug it into this formula to get the force required to stop it. So what's A equal to? VUAS, V squared equals U squared plus 2AS. 0 is equal to U squared. That's 2.25. Well, I better write 1.5 squared. 1.5 squared plus 2 by 0.05 by S. By A, not by S. So 2.25, and that's going to be 0.1 divided by 0.1, and that's going to be minus is equal to A. So just move the decimal one place, so we're going to get 22.5 is A, minus 22.5 ms to the minus 2. I should just put that in, keep my units in. So the force required to stop something of mass 2 with acceleration minus 22.5 would be 45. A force of 45 newtons is required to stop this gun going back further than 50 millimeters. And we can put minus in if you want, but that's obviously, we can put resistance force or force, and both are equally correct.